Hi everyone, my name is Vukasin Stojko and I'm one of the founders of Started and Tesla Nation. And I would like to welcome you to this event of Tesla Nation R&D, where we look at all the talent, all the R&D teams that are doing some amazing work in Serbia that can help create, well, the future of technology and the way that we live our lives and that we do our work by creating some amazing innovations. And tonight in particular, we have two really interesting topics that we'll be going through. Some people say, and perhaps with an increasing element of evidence to it, that the future of technology and a lot of human society will be based on blockchain. And definitely there's an interesting topic on that front here today. And also we'll be having a very interesting presentation about how, in a way, back in the real and present world, some teams have solved complex technical issues like creating a real-time messaging system for by using SMS. So hopefully you will be able to take away with you a lot of lessons learned and hopefully some inspiration and ideas. And we would like to invite you to go over through some of our older videos of these events and to keep in touch with all the future ones. Thank you for coming by, and thank you to our wonderful guests who will be sharing their knowledge and experience with us tonight.
Hello, everyone. My name is Lazar. I'm the CDO at Trapezis, and I just want to give a big thanks to Tesla Nation for having us come here and give a talk. We just came back from ETH Denver, a cryptocurrency and blockchain conference, and met a lot of amazing folk there. Hope some of them will join and really see that the future of Web3 and blockchain technologies is in a large part being built in the Tesla Nation Serbia. I want to hand over the microphone to Miloš, our blockchain protocol engineer and one of the coolest dudes I've ever worked with. Miloš, please tell us something more about blockchain protocol engineering.
Got it. Okay. Okay, so firstly, thank you to the Starry Center and Tesla Nation for giving us this opportunity to present here today. The topic that we're going to be covering today is this introduction to blockchain protocol development. And essentially, we're going to be covering three things. First of all, we're going to be covering who we are and why we're here. The second part of this presentation is going to concern this whole world of blockchain development and what does the current blockchain development landscape look like. How people can enter this landscape, and sort of what are some of the challenges that they can face. The third part of this presentation is going to concern general challenges with blockchains, challenges that we faced as a team while working on blockchain protocols, and hopefully it will be interesting for you. So first of all, a few words about myself and the team. My name is Miloš. I'm a blockchain protocol engineer at Trapezis. Trapezis is essentially a team of decentralized enthusiasts who are working on researching and developing blockchain protocols. Trapezis is also a venture of MVP Workshop, who I think for the past 5 years has been always pushing the boundaries and innovating in terms of blockchain technologies, not just in the region but even abroad. The team is, first of all, fully remote. We're a decentralized team. But really from all around the world. The majority of us are actually based here in Belgrade. We do have some people from Novi Sad, but we also have people from Japan and people who work in France. We also used to have people who worked from Spain, who worked from India. So pretty much all over the place. So why are we here today? We mentioned previously that we do blockchain protocol development. And one of the products that we're currently working on it's called Polygon Edge. So what is Polygon Edge? Polygon Edge, you can think of it as a very modular and extensible framework for allowing certain entities to deploy their own blockchain networks. And it's written completely in Golang. By its purpose and by its mission, it can really be described as a framework just to deploy your very custom blockchain with the parameters that you want. But this is something that we are going to cover later in the presentation. So you can think along the lines of Cosmos SDK or Hyperledger Besu or even Polkadot substrate for other non-EVM networks. We're developing this project in conjunction with Polygon Technology. So we're pretty much joined forces on this project. And the best part of working on this project is that it's completely open source. So all of our code, all of our basically workflows are completely open source and available to the public. So you can check us out on GitHub. So firstly, when we dive into this world of blockchain development, we really need to take a look at what is Adap. So Adap is essentially, it's short for decentralized application. It is essentially any kind of application that is built upon a decentralized network. So for our intents and purposes, for our use case, for this presentation, we're going to assume that that decentralized network layer is going to be a blockchain. And what dApps also provide is typically some kind of graphical user interface for users to interact with it and to just interact with other features of the app. So you really got to think about this in terms of abstractions. So you have this application layer, and you can think of this as your front-end facade for your application. So this is what users actually see. This is where users actually interact with your app. This is where all the buttons and the interactions are. And there is this sort of layer divide between your application layer and what's essentially below it, which is the blockchain layer. This is the decentralized layer that we mentioned earlier. So this blockchain layer can be any kind of blockchain network like Ethereum or maybe Polygon or Solana, blockchains like Near, or even a custom deployed blockchain network like Polygon Edge. So what are some of the prerequisites for people who want to get into blockchain development? dApps are usually built as completely web apps. Not all the time, but most of the time they are. And they just interact with the underlying blockchain layer through these browser extensions, MetaMask, and wallet connectors like Wallet Connect. So you essentially have your app that's written in either like some kind of front-end framework like React or Vue, and you use these frameworks just to interact with the underlying blockchain layer where you have all of your business and application logic. So what is a plus for developing dApps? So knowledge of JavaScript is definitely a plus. Most of the Web3 tooling that we have is built on top of JavaScript. So knowing JavaScript and just being comfortable with using JavaScript will really help you take advantage of the tools that are currently on the market. And knowledge of any front-end framework. I mean, this is a given. If you want to develop web applications that have GUIs, so something like React or Vue. React is, I think, most common in the Web3 space. So let's say you want to build apps on top of Ethereum. When you want to build apps on top of Ethereum, the Ethereum blockchain utilizes this thing. It's called DVM. It's short for Ethereum Virtual Machine. Essentially, it is a computational engine that works like a decentralized computer that at any point in time is executing millions of projects or millions of transactions. And it's executing these snippets of code that are called smart contracts. So smart contracts are really just that. So smart contracts are these very simple applications that are stored on the blockchain and that are run by DVM. And they only run when only certain predetermined conditions are met. So you can think of them as basically scripts that are written in this language. It's called Solidity, or they're written in for example, Viper as well. And they're run on DVM. We also mentioned here that Ethereum uses a consensus mechanism that's called proof of work. What is a consensus mechanism? For dApp developers, I don't think it's of too much knowledge, but a consensus mechanism essentially is when you have a blockchain network and when you have validators within a network, nodes within a blockchain network, how do those computers within the blockchain network agree on what is going to be the next block within the blockchain? They go through this entire process that is called agreeing on consensus. And essentially, the consensus mechanism that a blockchain uses significantly impacts either the performance of the actual blockchain or how fast your app functions, and other aspects that we're going to cover later in the presentation. Another great thing about Ethereum is there's a really good ecosystem for app tooling. So if you're an app developer who is already very experienced in JavaScript, you're going to be right at home with most of these tools. So tools like Hardhat, Truffle, and Ganache that let you bootstrap your own like little blockchain locally. Hardhat, which just makes the whole process of writing Solidity smart contracts much easier. And Ethers and Web3.js for you to use when you're developing smart contracts or when you're developing front-end applications that are actually going to rely on Ethereum. So what if you want to build apps on something like Solana? Like we mentioned on the previous slides, one of those blockchain layers can actually be, it doesn't have to be Ethereum, so it can be any kind of blockchain that you want. One of those can be Solana. Solana is fundamentally completely different from Ethereum. We mentioned smart contracts when we were discussing Ethereum, the snippets of code that the EVM actually executes. Those snippets of code, they're not called smart contracts in Solana, they're called Solana programs, and they're not written in Solidity, they're written in a programming language called Rust. And Solana uses proof of history, the proof of history consensus mechanism, which is different from proof of work. And we dug up these metrics on Solana and Ethereum from Twitter. Essentially, these are some metrics that app developers and blockchain operators need to take into account when they're choosing their blockchain layer. One of those metrics that is, I think, most important is the number of transactions per second. This is essentially how many transactions a blockchain can dish out within a single second. How fast can how fast can the blockchain actually execute transactions? The second most important metric is like the average fee for a transaction. So one of the biggest hurdles with blockchain adoption is definitely this hurdle of user experience, and having users pay significant transaction fees really hinders the user experience. For example, by this data, Solana, the average fee for a transaction on Solana was $0.0015 and for Ethereum it was $15. So for each transaction a user wanted to send, they would essentially pay this amount. The third most important thing that any dApp developer needs to take into account is this concept of transaction latency. So how fast do transactions actually execute? For Solana, that's 0.4 seconds, and for Ethereum, by this metric, it's 5 minutes. Other not as important metrics, I think, for dApp developers is this number of validators and the total number of transactions to date. The number of validators is just an indication of basically how centralized the network is, and based on the consensus mechanism that it uses and the number of validators, you can very safely assume how centralized or decentralized any kind of blockchain is. Okay, so let's say you want to build apps on top of something different, right? So you're scared away by the latency, or you're scared away by the average gas fees on Ethereum, or you just don't feel like you want to use Solana. Is there a solution for you? If you don't see a solution in any of the existing market mainstream solutions, right? And it actually turns out there are plenty of teams who think like you and who want to set up their own custom blockchain networks to accommodate their apps. Some of the reasons have been really previously mentioned in previous slides, but it essentially all boils down to one thing, and that's customizability. So when you're developing your decentralized application and you're choosing a blockchain layer, pretty much the last thing you want to be doing is not working on your app, but working on configuring your blockchain layer to fit your app. And this is a very huge, I think, time sink where you're spent configuring this blockchain layer and just tinkering around with how you can make your app work and how you can redefine your app just to fit in the underlying layer, when in fact you should be focusing on the application layer that we mentioned earlier. And it turns out there is a solution for this. It's called Polygon Edge. This is This is a product that Trapezis is actively working on, I think, for the past year, which allows you to deploy custom blockchain networks and to basically configure everything you want. So we're going to just recap all the challenges that we mentioned right here. So the challenges with the current blockchain development landscape is this concept of high gas fees. Users, for any kind of interaction with the blockchain that changes the state of the blockchain, they need to pay a certain gas fee. High gas fees, they basically kill the UX. There is this challenge of complicated setup. So setting up a blockchain layer shouldn't be any more complicated than just setting up any kind of tooling that you have for your app. What developers should be focusing on is working on their app and not configuring their blockchain layer. There's this concept that we touched upon earlier, which is concerned centralization. And this is just a fact. I mean, in blockchains, that some blockchains are more centralized than others. Meaning, if for example, like two entities have control over the majority of nodes in the network, they can influence any kind of transaction in the network. They can halt the network, and the more people you have participating, the more nodes you have participating within a blockchain network, that makes it more decentralized. This is an interesting challenge, cross-chain compatibility. So this idea that you can move assets between different chains is surprisingly cumbersome even today, and we're going to touch upon it later. And of course, the number one challenge is customizability. So teams should be able to customize their DApp blockchain experience for their end users and not have to worry about any kind of limitations or any kind of requirements that the blockchain may impose. So over the last year, the survey that we conducted with DApp teams and DApp developers, and we basically came up with a list of certain requirements all DApp developers have when they're developing, when they're looking for a custom blockchain solution. One of those requirements is definitely stability. So they want something that's tried and true. They want something that has been tested under load. They want to be sure that when they put their users and their app on the blockchain, on the custom blockchain technology that it's working on, they want to be sure that it's stable. Of course, speed is always a requirement, so block production needs to be as snappy as possible, so users can interact with the app as fast as possible. We also touched upon this earlier, this concept of Evm compatibility. So it turns out most DApp developers or DApp teams, that when they start out basically on the Ethereum blockchain, which means they write Solidity contracts. They're used to this Solidity tooling. Any kind of custom blockchain solution that they might switch to needs to be EVM compatible. So they don't want to be rewriting their apps, their business logic to fit a new blockchain. They just want to reuse the same old contracts, just reuse the same old tooling and expect it to work outside the box. So it needs to be EVM compatible. And of course, it needs to be customizable. So blockchain operators need to be able to customize pretty much every aspect of the blockchain experience, from the gas price to the number of blocks per second to the number of transactions per second. So it essentially comes down to this one question: how do you really build a blockchain? Well, it turns out diving into this whole question of building custom blockchain networks is not as easy as it seems at first. There are a couple of different aspects to answering this question, and different modules that need to be built in order for everything to work. The first module that any team that's focusing on a custom blockchain a blockchain solution should focus on is, of course, networking. So when you have nodes, they need to be able to communicate between each other, and not just to have communication protocols, but also to be able to exchange any kind of information and to find each other in the network. The second part is this concept of communication protocols, and this is just this doesn't even cover like the custom handshakes that you need to do, the validations, these fail-safes that you need to be put in place for your blockchain network to run. So you got to think about how nodes will communicate within a network. Now that you have like a networking layer. The third part, I think, one of the trickiest modules is definitely the consensus layer. So working on a consensus layer is involves this whole dance of trial and error. It's mostly just relying on your runtime, just relying on your module to be valid, and you do that by having a whole suite of tests and just testing every single part of your consensus mechanism, because in the end, this is where all of your transactions are going to end up to. And if your consensus layer is broken, then there's really no point in having a custom blockchain if your consensus layer doesn't work. The fourth part is runtime. So transactions and any kind of state execution data that you want, they need to be able to run somewhere. Usually, this is, if you want Evm compatibility, this runtime is like the actual Evm. So you need to implement the Ethereum virtual machine in order to be Evm compatible. And the final part to this diagram is optimizations. So now that you have all of these modules set up, it's time to pretty much trim the fat on every single module and just make sure that everything is as optimized as it could be. And this involves, again, like a lot of trial and error. And again, just figuring out what are the optimal limitations of your blockchain layer that you can have for you to be as fast as possible and deliver the best experience as possible. So what if you want to use multiple blockchains? Utilizing just multiple blockchains for cross-chain experiences is common, but it's surprisingly really tricky to support. Say you have, for example, an DApp application that's deployed on 3 networks. You have your DApp, it's deployed on Ethereum. You have a DApp that's deployed on Polygon network, and you have a DApp that's deployed on a custom Polygon Edge network that you set up. And you want to be able to transfer funds between all of those networks. This is called bridging. So if you want to move assets between different chains, different blockchains, you need to have bridging support. And the Trapezes team is actually really hard at work at developing a bridging solution for Polygon Edge that could be used for just bridging the gap between Ethereum, bridging the gap between Polygon, and custom networks that you set up. By now, I think it's really clear that blockchain clients have really a lot of moving parts, and Polygon Edge is really no different. But what it additionally offers in terms of in difference to, for example, Hyperledger Besu or any kind of EVM supportive client, is it offers this kind of modularity when it comes to pretty much all of the components of the stack. You have this JSON RPC module, which is your number one point of interaction with dApps. So dApps, any kind of decentralized application, is going to be hitting this layer, and this layer needs to be tested and it needs to work perfectly. This is your entry point into pretty much the blockchain. The other important modules that we have for Polygon Edge concern the transaction pool, so the place where you actually store transactions from users and where they're processed by users from users. You have the blockchain layer, which is pretty much the distributed ledger for any blockchain network. It just keeps data. You need to have a module for consensus mechanism like Polygon Edge, and of course have a separate syncing mechanism for other nodes. So not every node that connects to your blockchain network is going to be a validator node. Most nodes are going to be just like clients, as they're called, so they're just going to be syncing up state with the network. And on top of all of this, you need, of course, the networking layer that we mentioned. We, in Polygon Edge, utilize libp2p. And just to top everything off, we utilize gRPC for interaction between like the blockchain operator and the actual node. So these are some of the trends over the past year that we noticed with some of our partners. And essentially, we've gotten a whole plethora of answers, but all of it essentially boils down to this: they want low gas transactions. So most projects, they don't want to bore their users or just impede the UX with these high cost transactions that take a long time to execute, take a lot of user money. They want to minimize this overhead as much as possible. So low gas transactions are something that they're really looking forward to. They want configurable block time. So some projects have chains which they want to run. They want to dish out blocks as fast as possible, or maybe they want this increased security that having a delayed block production provides, like Ethereum does, for example, like 15 seconds, I think. Or they want to be able to configure it, right? So they want to say, okay, my blockchain is going to run for every 5 seconds, I'm going to dish out a block, or every 5 minutes, I'm going to dish out a block. They need to have this ability to configure it, and you can only do it with custom blockchains. Proof of stake, surprisingly, this I think surprised most of us in the team. Proof of stake is actually favored among clients. So most projects that we've been working with, they start off with proof of authority. Proof of authority is essentially where a single entity determines who is going to be part of the validator sets, so who is going to be in charge of block validations. Proof of stake moves this dynamic in a more decentralized manner. So pretty much anybody who has stake, they can become a validator, and they can move away from this centralized solution. Polygon Edge currently offers both POA and POS. So, for example, if somebody starts a blockchain with POA, later down the line they can move over to POS and vice versa. And of course, Evm compatibility. So, just moving all of the dApps to new blockchains is hard. Projects really want to reuse their existing code, which they audited, which they tested, and they just want it to work when they move, either to a new custom blockchain or to other blockchains. If any of this sounds interesting, you guys can check us out on the links provided. We have a QR code that leads you to our Getting Started page for our documentation. Following any of these links, you guys can just dive into the world of custom blockchain networks and blockchain development as a whole. And that's pretty much all for now. Okay. See the questions. Thank you for enhancing the image. Hi, are there any projects already built on top of Polygon Edge, or is it still in development? I'm actually not sure if I'm at liberty to say which projects we're currently working with. We have projects which are currently testing out and pretty much in the final phases before going to production. We have projects who are just probing whether or not they can use it with their flow. But I think soon we will have projects with like real production experience with Polygon Edge. But yeah, there's a significant number of projects that are currently using Polygon Edge for their custom blockchain networks. And yeah, if there are no more questions, I guess this is it. Thank you guys for the attention, and thank you for just taking a quick peek into the world of custom blockchain networks with Polygon Edge and the Trapezes team as a whole.
So, good evening. I'm Christos, CTO of Cron Studio. I'm here to talk about what we learned while we were developing an SMS sending platform. I'm glad being here, and I would actually I expected a long time to share these learnings of this project. So we can start with the presentation. 2 words about Cron. Cron is a company that works with the dedicated teams. Our values are user-centric, and we actually have people working for long-term as a dedicated resources. So what are we going to serve? We are going to serve the experience of implementing an SMS sending platform utilizing HubSpot. It's actually SMS Zap, an integration in sending that sends SMS messages. And the reason we want to share actually, well, this is a hard question, but I think it's that we would really, we value sharing, and we would really like to have this information ahead of time. So when you want to send SMS, for example, we know this coronavirus SMS messages, sounds like a trivial thing. You just, you know, find an SMS API and you just start sending messages. It's kind of more tricky considering these specific messages. Imagine that half humanity received plenty of them. So we are talking about like many billions of messages. And so the main business challenges sending SMS messages are that there are a lot of restrictions you cannot imagine before you start making SMS campaigns. There are content restrictions. Some countries, such as USA, have very specific and strict rules about marketing campaigns and content. We also had a lot of issues with fraud accounts. And we can have time-sensitive campaigns. You're sending something and you want it to be delivered today because it is about tomorrow. And also other challenges are about international support. An example of a mass campaign message can contain like some sort of generic message, usually with a person, and it can have also some specific token with your contact if they have it, your name, and so on, and some link that you can follow. There are one-to-one messages. We can send messages to specific contacts that we have stored in HubSpot. And in this case, you want this message to go instantly out, so you will get an answer right away. And of course, there are the frauds. They look like this. It's kind of hard to detect them. Usually, we detect them based on the URLs they are posting. And as I mentioned, there are restrictions. The most common, like you will meet, is that its number has a type. There are short codes, these numbers that are sending mass campaigns usually, and these numbers usually can send up to, let's say, 30 messages per second. There are toll-free numbers that are more restricted. It's not clear right now, for example, whether you can use toll-free numbers for mass campaigns. It's not forbidden. It's some of a gray zone. And there are virtual numbers that can send in the US, for example, 1 message per second. And in other countries, their speed is varying. And we have some other process that is called vetting for a specific phone number. When you have, for example, a 10 DLC campaign, which is an actual process that started now in the USA, you are vetting for the number so you can get a higher throughput. A similar case there is in India. You need to whitelist your numbers before you start sending messages. There are also anti-spam filters. Usually those are set by carriers. And the most important part, there are penalties. If you send messages out of sending hours in some country, or you're sending irregular content, your entire account can be canceled. Another issue is with the numbers. Imagine that the users are storing the numbers in their HubSpot system in various ways. They can insert them manually. They are inserting them through legacy systems, or they have some public forms that they collect leads. And the formatting of the numbers is not ideal. They are even storing like two numbers together in the same field, and they have like international prefix, local prefix, international prefix with plus, and so on. So we need to parse all of these like cases, and it's not always working well. Now, 2 words about HubSpot. So HubSpot is a CRM platform. So you can store your contacts, your leads, you can have your tickets, you can open deals, and so you can have involved contacts and employees of your company that are related with those deals. It also offers a CMS that you can create your website in HubSpot, and you can have all these forms in order to collect like contacts and leads and so on. HubSpot has natively made mail campaigns, and it supports integrations. So we built an integration, as we said, named SMS App. This is a one-on-one messenger. Here you can open a contact and you can say, I want to see the history of messages, or I want to send an instant message. This is a mass campaign. This actually is a browser extension because HubSpot integration doesn't support it, it was limiting us into workflows that I will present right after. In the workflows, you can also send mass campaign, but it is more complicated. As you can see, you have to set up some rules and so on, some targets. And so this is another aspect of our integration. Now, we had a lot of challenges, and the challenges were mainly related with time in a lot of manners. For example, we inherited some code from some teammates in the USA, and this legacy code had actually the proof of concept. It was sending SMS messages. It wasn't quite good, actually. It wasn't production ready, so we had to decide whether we will have a workaround or we will start it from the beginning. The time was pressing, so this is the first aspect of time, and so we decided to have a workaround. Spoiler alert, it wasn't a very good idea after we had to refactor everything into a scalable solution. And so what I will end up with is like some common stack that you could use in these sort of projects, and also some broader like approach of the problem. So our core stack is consisted by AWS and Heroku for hosting. We are using Vue.js and Python Django as a front-end and back-end, respectively. We have Redis as a message broker and in-memory database and caching. We are using PostgreSQL for our main database. We are using Celery for scheduling asynchronous messages in Redis. And we are using Docker. And the first system was all fully on Heroku. You know, this is a common practice when you want to start a workaround, and you are thinking, okay, I don't want to bother now, and you are going to Heroku. I would say that initially it sounded to be a good idea, but pretty fast became pricey, so we had to change that. So the main APIs we had was an SMS API, which is like the main part of handling and sending messages and all the webhooks from and towards HubSpot. There was a Hub API, which was like an intention to create a microservice that will somehow handle all this complexity of communicating with HubSpot, respecting, you know, some sort of limits and so on. And there was a core API that had like the user base and the billing. Each one of those microservices had its own database. And so we had also Redis with salary and the salary workers. So HubSpot for each individual message or for a mass campaign would send us a payload that looks like this. HubSpot portal is actually a HubSpot account. Imagine if Cron had a HubSpot account, this would have a portal ID. And so by receiving like actually by sending a mass campaign, HubSpot doesn't have the ability to send us batches. So even in that case, it would send us individual requests. And that was challenging. So the initial system looked like this. Actually, what happens here, I will use my mouse if possible. Maybe not possible. Okay. So I will explain. We have the message sending, this orange arrow to the left, and HubSpot is sending us webhooks to the SMS API. The SMS API doesn't access immediately the database. It goes through an asynchronous task in Redis, and the salary workers are consuming this, and they're sending messages. The whole story here was that this kind of microservice-like system wasn't designed for scaling at all. Actually, it would perform much better if it was a monolith application in the very early days. Doesn't mean this would solve any issues, but it would work at least like day one. So the whole problem was that each individual message would need to go to an individual worker instance, and it would ping both core API and hub API. And as you can imagine, this can be a mess. And the reason it can be a mess is that each one of these services goes down, the main workers go down, you're losing messages, and you're done. And this actually happened pretty easily. So it actually didn't need any failure to happen. We had some deploys to publish, and so the deploy was actually exploding the system itself. So we see a lot of issues here. We have dependency bottlenecks, we have deployment issues, lack of separation of responsibilities, a lack of throughput limit control. It was hard to maintain, it was practically unscalable. And so we decided to refactor, and here you have to spot the difference. Of course, we had a lot of iterations. So in the first iteration, we just tackled this guy here. So what we tried to do was we tried to reduce the synchronous requests. So we took off like this naive salary worker, which wasn't working actually well at all, with also message limits, number limits respects. And so what actually happens here is that we decided to get batches, to split these batches per sender phone number, which for simplicity now I will say its sender number is one different, like HubSpot portal and account. And so each one has just once to fetch the information about the number, speed. It has to fetch once like the logic, the tokens of the integration, and so on. So the idea was I'm splitting my queue. I'm fetching, let's say, 1,000 messages. I'm splitting my queue into batches, and I'm processing these batches using multiprocessing. And so I have some parallelism, which was another issue of the system. And so when you're done, you're just fetching another batch. We also included this like graceful restart, so we had the ability to actually have a better like kill mode to our system, so we can deploy without killing messages. So consider 3 senders, for example, that are in 3 separate processes. Sender A has some amount of messages, runs for this amount of time. you have sender B that goes all along till the end, and you have sender C a bit faster. And what happens here is actually you cannot guarantee how many messages you will get for each queue. And so, as you can see, also a number can be faster. So if you have, for example, 600 messages with 10 messages per second speed, you can finish in 1 minute. If you have like the half the messages, but 1 message per second, you can finish in 5 minutes, and so on. So all had to wait for this one slow. So we had to reduce our batches, because initially we started with something like 3,000, 4,000. Anyway, we want as much parallelism as possible, so we will do it this way, but this wouldn't work well. And so this happened one nice Wednesday. As you can see here, just to read the diagram, we have, for example, this is indicative. We have the number of active accounts that early days, and we have how many messages we sent in total that day. And what we realized was that this system is not related, with how many users you are gaining, but how much active your users are. And in that specific day, the 60+ thousands were sent just from one sender, and it was actually a new client, create an account, and next day, boom, they sent this. Of course, our system couldn't withstand this, and the databases started failing, not because of the main like worker stuff. This was kind of limited, but we had this like we had this delivery receipts that are coming back from the system, and they were pinging directly the database. And so this killed the system. And beside the fact that we tackled these two issues, we had a long list to solve. And so we had to go to refactoring again. And this time, we decided to be more radical, and we decided to get rid of some systems and to rebuild the entire logic of the system. And we focused in this guy in the middle, in the SMS worker, and we built around this worker whatever needed. We got rid of the hub API. We moved the authentication logic to the core API because it was more connected with the user authentication, so it made more sense to handle the tokens. And so we end up, we kept Heroku for our public APIs, and the reason was that we didn't want actually at that moment, with all this refactoring happening, to have to handle building, a redundant, like robust API, secure, and so on. So we kept on Heroku our APIs, but everything else moved into a Docker Swarm. And actually, we got some more instances in EC2, and we threw all the workers in the swarm. And this way, we actually here have much more workers. We split our Redis into 3 different instances. We have webhooks, we have a caching, and we have the main Redis that we're using for message queuing. And so we also have there some, let's say, internal part of the core API. And the whole idea was that we don't want to ping Heroku for internal users. So we still kept some sort of synchronous calls in order to avoid refactoring the entire thing at once. And so here, the main thing that happened was that despite the fact this flow looks pretty much the same, it is one way. And that is the most important learning of this system, that if you want to keep the system clean, you have to keep the data flow clean. So what happens here is that, again, we have HubSpot API pinging our SMS API. This goes to webhooks, and these webhooks will be somehow processed in chunks from SMS processing worker. The SMS processing worker doesn't care to wait in order to respect any limits. It just processes all the business logic And when everything is ready to be sent, it just hands this to main Redis, and this way it gets consumed by the SMS consuming workers. And this gave us the simplicity that the SMS consuming workers run in full speed. They just care to get messages and send them in a constant time. So what replaced this former SMS worker looks kind of like this. We have the ability to scale separately the SMS processing that process all the business logic. For example, is the recipient number real phone number? Is my account active? And so on. And also, it has the responsibility to parse the message for URLs, to check for fraudulent, and so on. And after, it will handle the message to consumers. And what happens with these consumers is that they run all in a constant speed. They are all the same thing, and they all run, let's say, for simplicity, in 1 message per second. So saying I have a number that can send up to 3 messages per second, this will be splitted when we have a batch of this number into 3 different queues equally. Now, the challenging part was, how do we split equally in real time and to keep it robust in long term? Because, okay, those workers are running, but you know, some worker can run slow, can need to restart to auto heal in the swarm. And this way, you have a thing that how do you know that you are keeping your queues balanced? So what we used there, since we already had experience with Redis supports natively Lua scripts. And the magic with Lua scripts is this. If you have 1 single instance of Redis and you call a Lua script, this will run in a single thread. And actually, this comes handy because no matter how many SMS workers are sending messages to your queue, you're actually capable to queue them one by one and to make decisions on the fly. Of course, the script has to be simple and fast because it runs and it blocks all the messages, but this was really fast and this performs really well. The logic is simple: get the least crowded queue. If your number is already sending in the maximum capacity, let's say you have to send up to 10 messages per second and you are spread it already in 10 queues, just find the least crowded queue in that among those queues and don't go further, and just queue the message and just let us know that it was done. And so this way, with this system, we tackled the most of the issues we had before. Of course, as I said in the beginning, we had like other kind of issues. One of the big issues recently, as the platform gained attention, was like fraudulent accounts. And so we're cutting the accounts in mainly 3 steps. First of all, we're checking for accounts that are connected and their HubSpot has like a non-existent website, or the website they attach to our account information, it doesn't match with the one that they claim they have in there. Mismatches in credit card info, such as locality of the credit card, which wouldn't stop, for example, Stripe of charging the credit card, is a no-go. Also, if they attempt to pay at least once with a stolen card, this is a red flag, and we are actually blocking the account right away. Also, we realized that they're using dev accounts on HubSpot, and recently HubSpot gave us the ability to detect that as well. So if we see that some account is using dev accounts, we are giving them very limited throughput, and they can test the platform, but they cannot really use it on production. And also we realized that they're targeting specific countries, so we took our measures checking these accounts. separately. Catching the URLs was a more challenging thing because we had to catch them in real time. It had to be automated. The first part is partially automated. We are getting some notifications, but we are not blocking the accounts in all cases automatically. In this case here, what we wanted to ensure is no matter in which time or what time of the day, we will have like a big running campaign. We want to check whether it contains URLs. We are sending these URLs in the background worker. So actually, we are not blocking the messages right away. If we get like that this URL is already like appeared as and it is whitelisted, we just don't check. If we see that this URL is suspicious by using some external blacklist APIs and so on, then we immediately block the message and we fail it. And if we see that an account has attempting to send like multiple messages like this, we block the entire domain actually. And so similarly, we have this this thing that if an account tried to send all these messages at once, we block the account as well. Something I wanted to mention is that you need to find a common stack. For whatever you're doing, of course, you can like, you're starting, you don't have experience with a specific like system, and you want to find like your stack, and you're, Googling stacks and so on. What I would say is that you have to find something that is at minimum scalable. So we made a sort list in order to ensure that we're answering the questions, what kind of stack we would use in our case. This, of course, can vary in your case. For example, for a clean data flow, you need some sort of event queues, to make asynchronous calls versus like synchronous API calls. And this complements any attempts like to implement microservices. You can use like FIFO queues, publisher subscribers. And the other thing is that if you want like graceful deployments, you have to use some sort of containers, Linux containers, Docker containers. And this, of course, goes together with modularity. So you don't want to be limited in one server that you set up one night at some point of time 2 years ago. You really want to have like this modularity. Okay, this server is down, we need to scale up. I take this thing from here, I go there. I want to go fully cloud, fully managed. I'm throwing a container like in a Swarm, in Kubernetes, and so on. And another thing is what I mentioned, and this was a tricky part because there is not a lot of documentation online, time synchronization. At some point, you will need to find a way to synchronize all of these, background workers and so on into one single queue. So what you need to do is to find a way to have some lightweight like thread or process save, let's say queue, that you will send everything there and will be consumed like in real time. I think in our case, Redis worked because it had this thing that the database is there. It doesn't go anywhere. It is in memory. We could use a Node.js service. It wouldn't be that fast. And that's why we actually kept Redis, and we are really happy with our decision. And now, in general, when you're going to data integrity in such a system, you will need some sort of like queues with data persistence. So whenever you deploy a worker, nothing will happen. Whenever a worker like has a failure, nothing will happen. Your queue will keep everything safe. And so broadening the problem, you have to think that what we share today is not all about SMS. It's not all about like, us solving this specific issue, or for example, sending emails would be like similar, let's say, but with less restrictions, most probably. The thing is that you can use the same like stack to implement, for example, your own data pipelines, let's say in machine learning. Redis actually has some modules for that. You can check it out. You can implement systems that can be distributed. You can shard your data here and there. And of course, another thing is this. Our initial team was consisted like by 3-4 people, and it was easy to say, hey, I'm deploying, don't do anything. You cannot go like that in a production system with a team that will grow. And actually, even in this small team, this was an issue. Beside that, imagine that in our case, when our accounts started covering all over the world, we haven't had any like time that the system was calm, besides some weekends in order to deploy. And as you all know, weekend is not a good time to deploy. Another thing is the power of simplicity. We really like the fact that we can like give now. In the beginning, we had this problem how to give to like to split the job and the workload, and to say, okay, I will get this task, I will get that tasks. And if you have like a simple worker that does a simple job and it does it well, then it's easier to maintain. You can jump into someone else's work and you will not get frustrated. Of course, all this will be complemented with a nice, like clean architecture, but this presentation is not all about the architecture. I would need to spend other like 3-4 hours to say like what are our like future plans or what we implemented actually in the system. This was, let's say, somehow simplified version of our system. So I would like to add some bottom line here. And I would say that you have to evaluate your decisions every single day, every single month. No matter what you decided and whether it was a good decision, today can be like obsolete. And think twice before you refactor or you decide to throw or not to throw some code of yours or legacy code of others. This was a big learning. In this case, we could save like 6 months and make it scalable. Find your minimum scalable stack day one. This is not over engineering. Don't think of this like, you know, it's not all about fancy technology. You need to solve the problem first. But really, if you go with fake it till you make it, this is like a caveat of a startup like logic. Okay, I will build a workaround, and when I gain attention, I will build the real system. Actually, if you know from the day one or from month one and so on that you have some issues, you have to find a solution. Sooner or later, implementing features will not matter anymore, because when one day from like 1,000 messages or whatever activity your servers have, you have like 60K, 100K, 500,000, then it will be too late to fix it. And so the most important part, and something that I'm really glad having at Cron, is that you cannot do it all alone. You need a team. Build a team. No matter how good you are, you need to have a team of people who care. So a team who cares is much, much more powerful of whatever knowledge you can gain in your entire like career as a software engineer. And somewhere here, I would like to you know, pass into the Q&A, and thank you for attending. Okay, yes. Yes, that is a very, very nice question. Actually, it was 500,000. It was a couple of years ago. Our system handled it, but we actually, what we had to solve, and it was this this kind of time-sensitive messages. So what I had to cut off my presentation because it would take like 20 more minutes was that our system, in order to respect the sending times, giving the ability to its HubSpot account, to its user of the platform, to set the allowed sending hours. And we detect the we combine this allowed sending hours with the recipient's time zone. So based on the recipient's like phone, we try to detect the closest time zone. And so what happens is that our system will schedule any messages that are sent out of times. But when you get a queue that is that big, we haven't had this check. So we queued all the messages. Everything was perfect. Everything was like queued, but the messages continued sending because they were already in the sending queue. And as I said, at that point, there wasn't like anyone to stop the messages. And now we added like a sort check in both sides. First of all, the Lua script will check whether we are running late, and how it will check that. It will check how fast is the number, how many messages the queue has, and if it sees that we are running out of time, we have like the actual timestamp that is the deadline for each specific message in the message payload, and so it won't send it, and so we have to schedule the message. Another thing that happens is that if anything goes wrong, our queue's running slow, we will stop the messages and schedule them on the other side. This is our fail safety. So yes, we had issues, and we are not ashamed to like say it happened. And next question. If there are no other questions, I see really nice comments, and I would like to say thank you for hosting us here, and have a great evening.